All right, so we're going to begin energy actually looking at a concept map. I had you guys do one for the landfill lab, and this is the concept map that Miss Tui actually put together last year for us for energy. But it's a great way to think about energy because as we go through the notes, which we're going to be starting today, there's a lot of concepts here that are related in different ways. So I'm just going to kind of give you like the bird's eye view of the whole topic, and a lot of this we're going to go into way more details later. So starting in the center with energy, just a couple definitions. Definition of energy is the ability to do work. Power is the rate at which energy is used. So we're going to measure that with 1 joule, which equals 1 watt per second. And so we usually use that as our conversion rate, and we're going to go over the math a lot more later. So kind of just keep a pin in that. A lot of times we will see units that we use will be things like kilojoules, kilowatt hours, megawatt hours, even gigawatt hours, which giga is going to be abbreviated with just a big G. So that would be gigawatt hours. All right. I want to talk a little bit about the forms of energy. There's like thermal energy, which we would think of as heat, mechanical energy, chemical energy. So there's a couple different forms of energy. And then just a refresher, we went over those. You probably went over those forms of energy when you did physics. And so in addition to the forms of energy, we also have the different laws of thermodynamics. So this is how we're going to like talk about how energy is going to be like used, basically. The first law is known as the law of conservation of energy. It states that energy cannot be created or destroyed in an isolated system. So you've probably heard of that one before. So basically, law of conservation of energy says energy is not going to be created or destroyed, but it could be changed. So we can have energy converted. A lot of what we're going to talk about is going to be the energy conversion from one form to another, maybe from the form of chemical energy into the form of mechanical energy or electrical energy. So we're going to convert energy. That's going to be one of our main things. And as we do that, because we are not an exact closed system or a perfectly efficient system, I guess I should say, some of the energy will be what we call lost. It's not really lost, right? The energy can't be destroyed, but it's converted into energy that is unusable. That's going to be like heat energy in many cases, or light energy if we're burning something. The second law of thermodynamics says that the entropy of any isolated system increases. That's that lost energy, in quotes. That's that energy that we can't really use. So that's our second law. The entropy is going to increase, and we get this energy that is kind of lost because it's not usable. So it's still there, it's just not usable. You will also see something talked about a lot, this EROEI. This is the energy return on energy investment. So this is how much energy are we able to use out of what we put in. Things that have, better efficiency are going to be better for the environment because we're going to be able to get more energy out of the energy that is there, typically. Today, we're going to focus on nuclear energy. You're going to do a case study on nuclear energy today, but nuclear energy is non-renewable. It involves the splitting of a large atomic nucleus into smaller nuclei. That's called fission. And energy comes from radioactive material. This energy, you are like using that radioactive material to heat water, creating steam, which turns turbines. And this is going to be a common theme we will see. In addition to what we're going to do with nuclear energy today with the case study, we also have to talk a little bit about half-lives. And I'm probably going to do a separate video on half-lives just to kind of go over the half-life math in a separate short thing that you can watch later. But just make sure you know that concept of half-lives goes in here as well. Then we have other energy sources that are non-renewable. So we kind of lumped all those together here under primary energy. That is oil, coal, natural gas. These are fossil fuels, non-renewable. About 83% of the energy is going to come from those fossil fuels. They have a pretty big impact on the environment. Again, we're going to talk about that later. And they have this externality cost. That means that the cost is paid by everyone, not just the people using the energy. So that's going to be a problem that we're going to kind of focus on towards the end of the future. Renewable energy is the other 17%. So 83% is fossil fuels or other non-renewable sources. So that could include our nuclear. Renewable energy, about 17%, could be the wave of the future. And it falls into about five main categories. Biomass, this could be solid or liquid. So solid would be things like wood, but this can cause deforestation. So the question of, is this sustainable, is one that we really need to think about. In Haiti, they have deforested much of the island because of using wood as the main source of fuel. Liquid biomass would be things like biodiesel or ethanol. And again, the question is this sustainable? Are we really getting as much energy return on the energy investment in growing the corn that might be used to create ethanol? Hydroelectric power can be broken down into a couple of different categories, just like solar power. So this is why I said we can usually break it into five categories, because all of these are related to water. So it's any power created by movement of water. But there's a couple different types. In general, we've got water turning turbines. We can use like tidal or wave energy. We can use run of the river, which means like you are not damming the river, you're just having the river as it runs turn a turbine. Or we can have dams like the Three Gorges Dam. And we are going to talk way more about those when we do the actual notes, but I just kind of wanted you to see like how we can kind of connect all of those together. Next is solar. Solar can be either passive or active. Passive solar we'll talk more about later. There's a number of different ways to do passive solar. Active solar is what you probably think of when you think solar power. That's the photovoltaic panels, the solar panels that you can like put on the roof of your house. They will convert that solar energy into energy you can use to power your fridge or your laptop. And you can go for it. Next is wind. Wind uses wind turbines. A lot of these are now being put offshore, which we'll talk about as we get into more details on the notes. And solar and wind are related because they are not consistent. Biomass, you can always burn it. Hydroelectric is usually a more consistent, regular thing, although if you're using the run of the river or the dam types, those do change with the seasons. And geothermal is consistent, but solar and wind, they vary a lot. If it's a calm day with no wind, or if it's a cloudy day with no sun, you're not going to get any. And then last is geothermal. Geothermal is energy from within the earth, from like radioactive decay. Or you can also get this energy from like places where there's like magma kind of close to the surface. So this is all energy from within the earth, heat. Iceland is a great example. You may have seen pictures of like monkeys hanging out in, actually, I don't know if that one is Iceland. But anyways, there's these like hot springs in the middle of ice, and you'll see pictures of, there's definitely pictures of people hanging out in them because it's one of the things that people can do when they go visit places like Iceland that have this geothermal energy. But you can actually get it from anywhere. It's just going to be better in some places than in others. All right, and then I also wanted to go over a couple of things because we're going to talk about these and just kind of talk about how these are related to that energy like concept map. So this is just information on dams. We're going to talk way more about dams later, but I wanted you to have that, and you'll have the image of all this on PowerSchool. When we talk about oil or any other of the fossil fuels, we're going to talk about the Hubert curve. Hubert created this in 1956, and this kind of shows us the rate at which we will expect to see declines in the ability to find new fossil fuel. We're also going to talk about fracking. Fracking is one way to extract some of this gases from shales. Basically, you use high pressure water, directing it at the rocks to release the gas inside. So fracking falls under the fossil fuels here. Fracking is not a energy generation it's kind of mining, a technique in mining that gets us the energy. And we didn't talk about it in mining because we're going to talk about it more in this chapter. And then fuel cells, hydrogen fuel cell vehicles, we may talk about. Any fuel cell is a device that operates like a battery, where electricity is generated. But in the case of the hydrogen fuel cell, what we are looking to do is take H2 gas plus O2 gas, get the energy out, and then our byproduct is water. Because the byproduct is water, this would be like a really clean method. Another thing we're looking at as like far as creating a new renewable fuel source is looking at algae to help as part of the process of breaking up hydrogen and oxygen to create the gases that we would need, or looking at algae to create like biofuel. So using that instead of like corn for ethanol. And then last, we are going to talk about the smart grid. The smart grid is really about like where's the energy produced and how do we move it to get where it needs to go, and how can we do that in a way that is more efficient. So that the smart grid kind of is going to fit in a weird spot on here because it kind of fits in its own separate category that we might call like use. And then we would have, the smart grid as one of the things we're going to talk about under use. We're also going to talk about, just like we did with the, other last chapter, reduce, reuse, recycle. In this case, we can't really recycle energy very much, but we can reduce it. So we're going to talk about reducing as well. So that's kind of its own little separate category. All right, so now we are, this is it for the concept map. This kind of just connects all these things from a bird's eye view. So we are going to go into details on lots of this stuff in the next couple sections of video.